All right, so we are doing a lesson starting with classifying triangles, which is something you should have done at some point in the middle school. But we'll do a quick review of it. So classifying by sides is what we're starting with. If we have a triangle that has three sides, 1, 2, 3, those little tally marks again mean that they're congruent to each other, then that has a special name. It's called the equilateral triangle. And when you have two sides that are congruent, just two, and the third side is not, we call that an isosceles triangle. Yes, you know how to spell those. And when no sides are equal, in this example they're all different lengths, we call it a scalene triangle. Okay, scalene triangle. So that's classifying by sides. In other words, if you have information about the sides, and you know that all three sides are equal, then you can call it equilateral, etc. Alright, now classifying by angles. When all three angles, so this means that the angles are congruent, so all three angles are congruent, then we call it equiangular. And we also know since the sum of the angles of a triangle add up to 180, and if they're all equal, that would actually mean that this would be a 60, 60, 60 triangle. Alright, in this one, we're assuming this, even though kind of looking at it, is an obtuse angle. And so this triangle would be called an obtuse triangle. It has one obtuse angle. Can it have more than one obtuse angle? No, because an obtuse angle is an angle that's over 90, and we know that they have to total to 180, although we haven't reviewed that. You've definitely done that in the past. This one has a right angle, which means it's a right triangle. And we are saying that all three angles are acute. Which means we would call this, based off the angles, an acute triangle. Alright, so that's the definitions of each of those. So you need to know the vocab and what goes with them. Again, if I'm trying to classify them because I know about angles, then I would name them based off of equiangular, obtuse, acute, or right. And if I'm trying to name it because I have information about the sides, then I would name it scalene or isosceles or equilateral based off the side information. Alright, so if point M is a midpoint of JL. Alright, well we should know what a midpoint is. Midpoint means that it takes JL, that point takes JL, and it splits it equally into two equal segments, or splits it in half. Half of the length of JL is equal to JM, half of the length of JL is equal to ML. Alright, they want me to classify triangle JKM. So JKM is this triangle right here. And they want me to classify it as either equilateral, isosceles, or scalene. Explain your reasoning. Okay, so listen, forget what you're trying to get. Just think about what you're given. What am I given and how can it help me? What does knowing the midpoint do for me? Well, knowing the midpoint, we said, based off the midpoint of JL, I know that half of JL is equal or congruent to LM. I know that half of JL is equal or congruent to JM. And I also know that JM is congruent to ML. Right? All of those facts. And that helps me with my numbers, because if the total is 1.5, then I know each of these is 0.75. Right? So based off the definition of midpoint, for all of those, definition of midpoint, we can take our 1.5 and divide it by 2, and that's where we got our 0.75s. Alright, and then you've got these little tally marks, which tell us that we know that KM is congruent to ML based off the markings. Which means they're congruent. Okay, so we know that those are congruent to each other, and so therefore Km is now 0.75, And now look, I got enough information to decide that since Kj is 0.75 and Jm is 0.75 and Km is 0.75, now I know this is an equilateral triangle. So in other words, use the givens just like you do in a proof. You've got to train yourself to think, I need to use what they give me and come up with more information. Probably not going to be one step for most of these. Find the measures of the sides of an isosceles triangle, ABC. Okay, well, isosceles, again, that's got to pop in your head and say, that means two sides are congruent. Which two sides? Well, they had to mark them for us. Okay, so based off these markings and the fact that it's isosceles, we know that 4x plus 1 has got to equal 5x minus a half. And now you're doing your algebra. I got x equals 1.5. And they wanted me to find actually the measure of each side. Okay, so I didn't finish yet, I just found x. So AC is going to equal 4 times 1.5 plus 1. Or AC is going to equal 6 plus 1. So AC looks like it is 7. And then I've also got to find AB. AB is equal to 9 times 1.5 minus 1. So AB is equal to 12.5. And BC, this is where I check to make sure we're right. 1.5 times 5 minus 0.5. And BC comes out to 7 again. So a good check for us to make sure we didn't mess up our algebra anywhere. AC and BC are actually equal to each other. All right. Next page. Find the measures of the sides of the triangle DEF and classify it by its sides. All right, so now we're on a grid. So we plot our points. I got -5, 9. I've got 2, 1. And I've got -8, 3. F being -8, 3. E being 2, 1. And D being my negative. And I'm drawing my triangle. Okay, so you have options. We're trying to find the measures of the sides to decide how to classify it. So what do we need to know? We need to know the length of DF, the length of DE, and the length of FE. So you have options. You can, to find the measures, you can use A squared plus B squared equals C squared, since I'm on graph paper. Makes it easy unless you plot wrong. Or you can use the distance formula. x2 minus x1 squared plus y2. It's really the same thing, just one manipulated, right? Distance formula if I just want to go by the coordinates. All right, since I'm already on the grid, it would be pretty easy for me to just set up some right triangles for myself. So I know to find FE, so it would be 2 squared plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 squared would equal EF squared. So 104 is equal to EF squared, which means EF is equal to square root of 104. And again, negative square root of 104 is also what you would find algebraically, but it's geometry. So we would reject that negative anyways. So we're just keeping E equals square root of 104. 104 for that. They did not say we had to simplify, so I'm not going to simplify here. Unless you need to practice. Alright, I want to say I want to find DF now. Okay? I want to count. I'm going 1, 2, 3, 4, 5, 6. So 6 squared plus 1, 2, 3 squared equals DF squared. I got 36 and I got 9, which gives me 45. So 45 equals DF squared, which means DF is equal to square root of 45. Again, you can simplify if you want, but you don't have to. The directions don't say you have to. So square root of 45 for DF. And then finally, step 3, I'm trying to do DE. So 1, 2, 3, 4, 5, 6, 7 squared plus 1, 2, 3, 4, 5, 6, 7, 8 squared has to equal DE squared. Put that in your calculator and you should get 113 equals DE squared. Square root of 113 equals DE. Alright, so we found the measures of the sides of the triangle. Now we want to classify it. Okay, well what do I notice about all three of these sides? None of them are equal. Okay, well then that means that it is a scalene triangle. Based off the sides, I'm using scalene equilateral isosceles. Alright, so you can do it off graph. Okay? Alright, going on to angles. So sum of the interior angles. Triangle angle sum theorem. Alright, well you already know this. We've actually already mentioned it today. The sum of the interior angles of a triangle equal 180 degrees. Alright? And the picture of this, which I'm just going to listen now, you don't have to write this down. But if this was my triangle, this was a sheet of paper right here. Right here's my sheet of paper, and I cut out a triangle. And then I took this angle, I took scissors and I cut that off. Okay? And I took this piece right here, I could slide it up into that spot, right? And it would fit perfectly. And I could cut off this piece and I could slide it up, this corner right here, and slide it up into that piece. And so this angle and this angle and this one in here, they would add up then to 180 because they're giving you that half a circle. Okay, I can demo you that in class on Monday if you remind me. Alright, so that being said, how do we do that more formally, like with a proof? That's just kind of like a demo idea on why it works. But if you think about it, if we know we draw in a line, an auxiliary line that's parallel to CD, okay, so we know that those are parallel, and these are transversals, right? It doesn't matter which transversal you take. So then I'm going to use numbers here. I'm going to put numbers in. We call this angle 1 and this angle 2. Then I could say that angle 1 has got to be congruent to angle 2. I also know 3 is congruent to angle 4. That's a given. And my reason here is what? If parallel, alternate, interior angles are congruent. Okay, so we've got alternate interior angles are congruent. And then I also know that angle AEB would have to equal 180 degrees. Definition of straight angle. And since it equals 180 degrees, and this is just, we're just going to talk our way through it. We haven't done formal proof with these reasons, but just think about it, it makes sense. If I take AEC, angle AEC, or angle 1, actually I'll call it angle 1. If I take angle 1, and I add it to angle CED, which is what we were just talking about before, plus angle 3, it's going to equal 180 degrees, because parts of an angle added together equal the whole. Parts of an angle added together equal the whole thing. In other words, angle 1 plus CED plus 3 is equal to this whole angle AEB, right, which is 180 degrees. And we're being a little bit informal here. We're just trying to get the idea of why this is the case. And then based off of that, instead of saying angle 1, since 1 and 2 are both equal. We're going to do this all in one step. Normally we do this in a couple steps. We're just trying to get the idea. So since 1 and 2 are equal, I technically then could say 2, leave it with CED, and instead of 3, I could say 4, and that would have to be equal 180, and that would be substitution. I just replaced it. Again, I would do this in multiple steps if I was formally doing a proof. We're just trying to get the idea where this theorem comes from. So that's a couple substitutions, but we're just getting the idea here. Okay, so then basically what we just did was prove what we just came up with here. We said that we know the sum of the interior angles of a triangle are always going to add up to 180. And you can see that based off the alternate interiors and a combination of straight angles and some substitutions. So this is just a general idea. It's not a formal proof, like not the way you would necessarily do it on test or quiz. You would need some extra steps, but gives you the idea of where that theorem comes from. Rather than just me telling you the theorem, that's where it comes from. Okay? Alright, so let's see. Let's use some of this. If the degree measures of the angles of a triangle are represented by the following. Okay, draw pictures. Listen, it's geometry. Draw pictures. And it doesn't matter if your picture is accurate. You're just trying to get an idea. One of the angles is 2x. One of the angles is x plus 10. And one of the angles is 3x minus 10. Okay, so then what do we know? What did we just say? Well, I know that all three angles in any triangle, any interior angles, always add up to equal 180 degrees. Okay, so 2x plus x plus 10 plus 3x minus 10 has to equal 180. Justify or explain why. The interior angles of a triangle, the sum of the interior angles of a triangle equals 180 degrees. There it is. And then it becomes algebra. No more geometry here. So we got 6x equals 180. The 10's cancel out. And x equals 30. All they want to do was find x, so I am set on part A. Part B, find the degree measure of each of the angles. Okay, well then one of the angles is 2x, so 2 times 30 tells me that one angle is 60 degrees. Okay, the other angle is 30 plus 10, which means the other angle is 40 degrees. And if I've done this correctly, then when I plug in I should get 80, right? So 3 times 30 is 90, take away 10. Oh, there's the 80 I was looking for. So check, they all seem to make sense. There's the three angles. Classify the triangle by its angles. So now we're not talking scalene or isosceles equilateral, we're looking at the actual angles of this. Alright, and 60 degrees is definitely not a right triangle. We've got that. It's not equilateral because they're not all, or equiangular because they're not all 60. But my choices are obtuse or acute. Well, all three angles are acute, so that makes this an acute triangle. Alright, a couple more, and then you can work on your homework. Alright, you've got a triangle. Alright, let's draw our picture again. Again, not so worried about you being accurate with it, more just a visual for you. I need an A, I need a B, I need a C. Angle A is 40 degrees, angle C is 30 degrees. And if CD is drawn so that CD bisects angle C, okay, if it bisects it, it splits it into two equal angles. Okay, so I'm going right up the middle of that angle, and I now know, if this is a bisector, that those angles are equal, okay? And this is going to be D where it ends. As they told me to name a D on AB. All right. Find the following. Okay, well let's just forget what we're trying to find. Let's just fill in what we know here. So I know if it's a bisector, then I know that half of angle BCA is congruent to angle BCD. I know that half of angle BCA is congruent to angle DCA. And I know that angle BCD has got to be congruent to angle DCA. I know those are definitely true, and I know the total is 30. So if they've got to be equal, I can take that 30, half of BCA is equal to DCA. Okay, so take half of 30, and it's going to tell me what DCA is, right? So angle DCA is 15. Common sense. So this is 15. This has got to be 15 because they're equal. And then I can look at this triangle, which I have the next most information about. And now I'm looking at triangle ADC. Okay, and in triangle ADC, I know the sum of the interior angles has to add up to 180. So 40 plus 15 plus angle ADC has to equal 180 degrees, because in a triangle, the sum of the interior angles equals 180 degrees. You should be writing this stuff out because it helps you remember it. All right, which means that angle ADC has got to equal, ADC would equal 125. So they add up to 180. All right, so we got ADC. And then, if you notice, next thing I would notice, and there's different ways you can do this, but next thing I would notice is that angle BDC is supplementary to angle ADC. Why? Because linear pairs are supplementary. Okay, and how do I write that out algebraically? I write it as angle BDC plus angle ADC equals 180 degrees, okay, and I know that, I don't know, not BDC, sorry, BDC, BDC plus ADC. So BDC I don't know, but I do know that ADC is 125, and I know it's got a total to 180, which means BDC has got to be 55. So that's 55. And then I have options. So I've got triangle BDC, which I could add up, or you could look at the big triangle, triangle ABC, right? If I look at triangle ABC next, so what was this? This was step 1 we did, this was step 2 we did, this was step 3. Just going over here, a little out of order here. So 4, let's say I look at triangle ABC. Again, you might do it a little bit differently. I look at triangle ABC, and I know that angle A plus angle B plus angle BCA has got to equal 180. So angle A is 40, angle B I don't know, that's what I'm looking for, and angle BCA is 30, and that equals 180. So that means that angle B would have to be 110. Alright, there's angle B. And obviously the phone's ringing, but this is pre-graded. Okay, so I got 1 minute left. All right, in triangle ABC, I draw a picture. The measure of A and B are in a ratio of 2 to 5. Okay, so we know that we make that 2x and 5x. And the measure of C is 72 more than whatever A is. Well, A is 2x, and it's 72 more than that. So 2x plus 72 more. And now I want to find the measure of each of those angles. Okay, so then 5x plus 2x plus 2x plus 72 has to equal 180. Why? Because in a triangle, the sum of the interior angles equals 180 degrees. All right, so now I'm with algebra. I got 9x plus 72 equals 180, which means 9x equals 108, which means x equals 12. All right, and what do they want me to find? They don't want me to just find x, they want to find the measure of each angle. All right, so angle A is equal to 2 times 12, or 24 degrees. Angle B is equal to 5 times 12, or 60 degrees. And the last one, if it's correct, right, should add get it to equal to 180. So 2 times 12, which is 24, plus 72 gives me 96. Okay, so I'm thinking these are my angles. These are the measure of my angles. And when I add them all up, I get 24 and 96, which is 120, and 60 is 180. Perfect. All right, so that's your lesson for today. And I will see you in class next time. So get your homework started and or done. See ya.